Hello and good morning, everyone. Today I'll be attempting to solve and explain one of the questions that we have came across during the past few weeks. This is the question that I chose. It is the limit of 1 minus cos theta over 2 sine squared theta. We have came across this question twice on both of our retake exams and once in one of our AP College Board assessments, if you remember. Now, solving this question. This is the way that I solved it. These are the steps that I used. Now I'm going to try and attempt to explain them. The first step that I have done during the solving of this question is I've taken the 1 over 2 outside of the limit because it is a constant with respect to theta. The second thing that I did, the second step, was to evaluate both the numerator and denominator's limits. So if we evaluate the limit of 1 minus cos theta, it will equal to 0, and sine squared theta, that will also equal to 0. We'll be left with this now. Since 0 over 0 is of intermediate form, now we are going to apply L'Hopital's rule. Since we have already evaluated the limits of both the numerator and denominator, it is time to evaluate the derivative of both the numerator and denominator. Thus, the next step. So in the fourth step, I found the derivative of the numerator and denominator, thus giving us the next equation, which is 1 over 2 limits of theta going to 0 is sine theta over 2 cos theta sine theta. If you're confused about how we got from this to here, it's by using the sum rule and differentiation. After this step, we are also going to evaluate the limits of both the denominator and the numerator, giving us the limit of sine theta, which is equal to 0, and 2 cos theta sine theta is also equal to 0. This expression contains a division with 0, which means that this expression is also undefined. And since 0 over 0 is of intermediate form, as I said before, we are going to apply L'Hopital's rule. L'Hopital's rule states that the limit of a quotient of functions is equal to the limit of the quotients of their derivatives, thus giving us this following expression. Now we are going to find the derivative of the numerator and the denominator of this function. And if you're questioning or if you're asking about how we got from here to here, we used differentiation and both the power and product rule. Next, we are going to take the limit of each term, so the limit of cos, the limit of 2 cos squared, and the limit of negative or minus 2 sine squared. After we're going to take the limit of each term, we are going to evaluate the limits by plugging in 0 for all concerns or all occurrences of theta. Now we are just going to solve and simplify this expression. So the cos theta or cos 0, the exact value for cos 0 is 1, and then so 2 and cos again, so it's going to be 1 squared, sine, the exact value for sine is going to be 0, and we are going to solve continuously, thus also getting 1 over 2 times 1 over 2, which is also equal to 1 over 4. Go back to the question, it was option C, and so that is how you solve this question. If you have any questions or any concerns about this, please ask me. Thank you.